This is the lecture for lesson 19. This lecture is going to cover linear functions. We will start with representing a linear function from a table, determining if we have an increasing, decreasing, or constant function. We will interpret slope as a rate of change, and then also look at some real-world applications and graphs. This table represents a linear function, and we need to write the equation of it. If we remember, that is y equals mx plus b, where m is the slope and b is the y-intercept. So for slope, we just need to pick a pair of points. It doesn't matter which pair we pick. So let's pick this pair. We need to find the change in y and put it over the change in x. So 5 to 3 goes down 2. X, negative 2 to 0 is going up 2. So the slope, change in y over change in x, negative 2 over positive 2 is negative 1. The second piece you need is the y-intercept. So you're going to look where x equals 0. So x equals 0 is here. What is the y-intercept? The y-intercept is 3. And once I have those two pieces, I can go ahead and put them in my equation. Instead of y, we're using the function h of x. So it's negative 1x plus 3. You remember we did this back in the second chapter. Now we want to go the opposite way. Again, we've worked with functions here, and we've given a function and asked to plug some values in. So let's go ahead and do that. So we want to find g of negative 4. 5 times negative 4 minus 2 is going to give me negative 20 minus 2, or negative 22. If I want to find g of negative 2, I'll have 5 times negative 2 minus 2 is negative 10 minus 2, or negative 12. And the last one, if I plug in 0, 5 times 0 is 0 minus 2, negative 2. So hopefully this at least is a review of what we did before. Do we have an increasing, decreasing, or a constant function? Well, let's recap. Remembering that y equals mx plus b, if m is a positive number, we have an increasing function. And that's what this first one says here. Increasing if m is greater than 0. So m is positive. If the m is less than 0 or m is negative, we have a decreasing function. That means our line goes down from left to right. Positive goes up from left to right. Any constant function, there's actually not going to be any slope. It's just going to be f of x equals some number, no x's on that side. And the result's going to be a horizontal line. So if we take a look here, first function, f of x equals 5 minus 2x. So slope is negative 2 because that's what's attached to the x. So this is a decreasing function. B does not have any x's, so there is no slope, meaning we have a constant function. And the last one, our slope, the value that's attached to x is 4, positive, meaning it is an increasing function. We've worked with slope before, but now we've got a word problem that we need to translate into points to then be able to find our slope, or more commonly called a rate of change when we're talking in real world. It says the population of a city increased from 16,000 to 24,500 between 2010 and 2015. If we assume the change was constant from 2010 to 2015, find the rate of change. So one way to do this is to pair those points. So in 2010, the population was 16,000. And in 2015, the population was 24,500. And then once I have my pair of points, x1, y1, x2, y2, I can calculate my slope. y2 minus y1 over x2 minus x1. So y2, 24,500 minus 16,000 over 2015 minus 2010. So that's going to give me a difference on top of 8,500 and a difference on bottom of 5. And when I do that division, I get 1,700. So now we want to put this in terms of what we're talking about. So it says we know that our slope is always change in y over change in x. So y was the population, x was the year. So we got 1,700 people per year was our increase. Jason wants to save money for a trip. He started with $170 and after 4 months he has $630 saved. Find the rate at which Jason is saving his money. So we want to figure out how much money he's saving per month. So money per month. So we can think about how that increase went. So 630 minus 170 is the money change over 4 months. So if I take 630 minus 170, that's $460 that he gained over 4 months. And if I do that division, I get $115 per month as what he is saving. Now we're going to take a real world problem and turn it into a function. In 1968, 23% of the grades for students entering college were a C. This has decreased at an average rate of approximately 0.45% per year since then. Write a linear function in slope-intercept form that models this. So we need our starting point and we need our slope. And our slope is where it says the rate. So our starting point was 23%. That's our B. Our slope or our rate, our M, it says has decreased at an average rate of 0.45 per year. So decreased meaning minus 0.45, and there's my slope. So our equation, our function f of x is going to equal slope negative 0.45x plus 23%. Or if you want to think about it, 23 is the start minus 0.45x. Either way, it does not matter which one you put first. Just that the 23 is positive and that 0.45 is negative. Julia's writing a cookbook and she currently has 35 recipes. Every month she adds 7 recipes to her cookbook. Write a function that models this and how many recipes she will have in her cookbook at the end of the year. All right, well, if we start with our function, we start with 35. So she currently has 35 recipes and we're going to add 7 per month. So I'm going to add 7 and then x. So I'm going to let x represent months. Now this one wants us to go one step further and it says, how many is she going to have at the end of the year? Well, a year is 12 months. So 35 plus 7 times 12. We want to find the function evaluated at 12. 35 plus 84 is going to give me a total of 119 recipes. Next, we're going to graph some linear functions. The first step is to plot the y-intercept, and then the second one is to move the slope. Remember that slope is always 2 directions. We will move up or down first, and then we will move right. So if it is a positive slope, we move up and then right. If it is a negative slope, we move down and then right. When I look at this first function, it says the function is negative x minus 3. So starting with the y-intercept is -3. So on the y-axis, I'm going to find -3. Then I'm going to move my slope. Now my slope is always two directions. So -1 is all I have. I'm going to put it over 1. So down 1 over 1. And in Newton, all you need is 2 points to be able to draw your line. I'm going to follow this pattern here just so I can make a nice line on my slide here, because the more points I have, the more accurate my line actually can be straight. There you go. Second one is the function is 2/3 x plus 3. So this one we're going to start at our y-intercept of +3. And then our slope is 2/3. So I'm going to go, it's already in a fraction form, up 2 and then write 3. So if it's not in a fraction form, you put it over 1. If it's already in a fraction form, you have both pieces. So up 2 over 3. And then I'll repeat that just so that I can make a nice line here. And there's your function. This last section here is, again, just more applications with linear functions working with word problems. Laura received a $90 gift card for a coffee store. She used it in buying some coffee that costs $12 per pound. Write a linear model that represents the situation, and then find the number of pounds she can buy with a gift card. Well, this is our starting value. So she starts with $90 on that card. When you purchase something on the card, your value is that purchase is deducted from the total value on your gift card. So that means I'm going to subtract $12 for every pound of coffee I'm going to buy. So x equals pounds of coffee. So we started with $90, and I'll subtract $12 every pound I buy of coffee. That is our function. If we want to then find the number of pounds that she can buy, well, I want to know, I want my balance on my card to be 0. I always hate gift cards because sometimes you get to that point where you end up with like 15 cents on the gift card. We want to get all the way to 0. So where does the value equal 0? So I'm going to set 0 equal to 90 minus 12x. If I add 12x to the other side, I now have 12x equals 90. I can divide by 12, and I will get 7.5 pounds of coffee that I can buy if that's the only thing I'm buying with my $90 gift card. Next example, Ryan purchased a prepaid phone card for $20. Now, this is probably back before some of you were even born. You actually could purchase a prepaid phone card and use it on a payphone. So whether this is something you're actually familiar with or not, let's follow the situation. Long distance calls cost 8 cents a minute using this card. Write a linear model that represents the situation. So we start with $20 on the card. Every minute that I talk, I'm going to lose 8 cents. So I'm going to need to subtract 8 cents. So 0.08 is 8 cents, x, and x is going to represent minutes. So there's our function. Start with $20, we subtract 8 cents per minute. How many minutes can Ryan talk on the phone if he uses the card completely? So again, we want the entire balance to be gone. We want the balance to be 0. So 0 equals 20 minus 8 cents x. I'm going to add the 8 cents to the other side. So I get 8 cents x equals $20. If I divide by the 8 cents, I get an answer of 250 minutes. On Super Bowl Sunday, Viewers of the big game expect to be entertained by commercials that offer an upbeat mix of punchlines, animal tricks, humor, and special events. The price tag for a 30-second ad slot cost $2.2 million in 2003 and $2.7 million in 2009. Predict the cost of a 30-second of ad time in Super Bowl 2015. So we start at $2.2 million in 2003. We go up to $2.7 million in 2009. So that means we increased $0.5 million over 6 years. If I take 0.5 divided by 6, and I put that in fraction form, it's going to give me 1/12. So our function, we start at 2.2 million, and we're going to increase by 1/12 of a million every year since 2003. So x equals years since 2003. That's important because we want to find the 30-second ad time cost in 2015. So 2003 to 2015 is a difference of 12 years. So if we now plug in 12, 2.2 plus 1/12 times 12, that's going to give me 2.2 plus 1, or 3.2 million in 2015. In 2007, it was recorded that the U.S. government paid $520 billion in Social Security and $920 billion in 2016. Predict how much the U.S. government will have to pay in 2020. All right, so same process. We start in 2007 at $520 billion. And then by 2016, we are at $920 billion. So we know our starting value is $520 billion. And we know we're increasing here. So let's figure out how much we increased by. 520 to 920 is a difference of $400. And from 2007 to 2016 is a difference of 9 years. So when I do that division, I get 44.4 billion per year. So I'm going to add 44.4 billion every year. But remember that this is years since the start, 2007. So if I want to predict 2020, well, 2020 from 2007 is a difference of 13 years. So 13 is going to be my x. So 520 plus 44.4 times 13. And if I take 44.4 times 13, that gives me 577.2 that I need to add to 520. And that is going to give me 1,097.2 billion. Because we have to remember that all of our values back here were in billions. This is the end of the lesson, so you can go ahead and do your homework.